So this is the next chapter, steam generators or boilers, because in this course of power plant and desalination, we already covered the complete power plant cycles, whether it's a uh, steam turbine power plant or it's a gas turbine power plant. Then we also covered the combined cycle power plant. After that, we started to discuss the components of power plants. So we already covered nozzles, steam nozzles, and steam turbines. Now this is another important component of any power plant, that is steam generator or boiler. This is where the steam is produced actually in that component. So we shall go through this chapter. It's a short chapter, so already time is very short. Okay. So what is boiler? It's not that a rocket science. It's a very simple device in which water, the liquid water, is converted into gaseous water. So it's a closed vessel, as you can see here, where water is converted into steam by supplying heat. And this heat can be supplied by a burner where air plus fuel mixture reacts and produce heat. Fuel could be any kind of fossil fuel, natural gas, oil, or coal. All right, or maybe we can also use biomass. All right, so boiler is just a name to any such vessel which is used to produce steam. All right, so the major requirements of a boiler: it should be safe, of course. It should have high efficiency. Its overall design should be compact. All right, easy to maintain, easy to maintain. It should be cost effective, of course, and it should start quickly. So quick startup. So these are some of the requirements from any boiler. Okay, one important thing in steam power plant, we already use this DS diagram to present the boiling process. Right, and if you remember, it was after pump. Now this was the process in which heat is applied to that water to convert it into steam. But specifically, the term boiler is only used for this portion inside the dome. That is where actually the boiling is taking place. And that is the core steam generating unit. Maximum heat is normally supplied in this part compared to, if I say this is boiler, then this one is Q, which we supplied in the superheating device, and this is the heat which we normally supply to the feed water. Normally it is done in a component which is called economizer. All right. So the boiler, strictly speaking, the boiler is this part only, the middle one. Okay. These two parts, economizer and superheaters, they are actually separate components. So this portion which we see here in this figure is actually this middle part, right? Economizer and superheaters are separate components which are added to improve the performance. So not all boiler types include these economizers and superheaters, right? Especially for low pressure or older designs. But nowadays in modern boilers, these economizers and superheaters, they are kind of essential components in modern high efficiency systems. So a boiler does not require an economizer or superheater to function. These are just these two, economizer and superheaters. They are just performance enhancing accessories. So they are installed normally externally or integrated in new advanced boilers, but they are not a part of the fundamental definition of that boiler. Those does not include this economizer and superheater. Okay. Okay, so this is just the simple theory. Now let's move on. So here in this figure, you see key components of any boiler. So here we see a burner, right, where fuel and air means air oxygen basically. They mix together and with some kind of ignition device, they produce that combustion. All right. So here is the combustion chamber where this combustion actually takes place. And from this combustion chamber, these hot gases, they are sent into a heat exchanger. So within this boiler, there is this part where heat is exchanged between the water and the gases. And there should be a proper control to regulate, for example, here to regulate the ignition device, right? This firing rate, depending upon the requirement. When you need more steam, then more air and fuel mixture needs to be burnt. So this control unit is actually controlling this ignition, firing rate, and also this air and fuel flow rate or supply. Also, this exhaust that is very exhaust draft. These exhaust gases should leave the structure easily without creating any extra pressure here. So, and also this control unit is monitoring the water temperature, right, which is required, and also pressure, so that accordingly it will control the ignition, firing rate, or air fuel supply. So these are the basic components which are shown in the form of a schematic for any boiler. Right. Okay, these are explained here. Not that difficult. Let's move on. Now we can classify boilers on the basis of, for example, flow of fluid. If the water is flowing inside the tubes and air or the combustion gases are flowing outside the tube, then these are called water tube boilers. So these are some industrial boilers which are used. These are the names of those boilers. For example, Babcock and Wilcox and Lamont. These are some practical examples of water tube boilers. The other type of boiler is fire tube boilers, as the name indicates. Now the combustion gases, they are flowing through the tubes and water is outside the tubes. Then those are called fire tube boilers. For example, Cochrane or Lancashire boilers. So we shall see their schematic, some of them in these slides. Then depending upon the position of the furnace, it could be just like internal combustion engine or external combustion engine. So here we can also classify boilers on the basis of position of the furnace. It could be internally fired, for example, this Cochrane boiler, or it could be externally fired like Babcock and Wilcox boiler. So we'll see their schematics in a short while. Axis of rotation, boilers could be the boiler shell. It could be placed horizontally. For example, we will see this Lancashire and locomotive boilers. They are horizontal type boilers. This could be vertical type boilers like Cochrane, and the boilers could be inclined. Their axis could be inclined. These are less common. Those may be used for some special applications. Mobility, boilers could be stationary. All right, for example, Babcock and Wilcox or Lancashire boilers, these are stationary boilers, and mobile boilers, as you know, locomotive or marine boilers, they are mobile boilers. Circular type, it could be natural convection. For example, in these types of boilers, the circulation of the water is by natural convection, or it could be by forced convection, for example, Lamont or Benson boilers. Okay, so that's how the boilers can be classified and categorized, right, according to this criteria. Now let's further see. We can also classify boilers on the basis of pressure. For example, some boilers are low pressure boilers, some boilers can be classified as high pressure boilers. Their names are mentioned here. So, what is typically meant by pressure, low pressure or high pressure? So, here are some values of those pressure ranges, which can be tagged as low pressure. For example, if the pressure is around normal atmospheric pressure, either we are producing heat or just hot water. So then these are called low pressure boilers. For example, the boilers which are used in residential or commercial water heating systems or small process heating in industries. Medium pressure, if we are producing steam in this range from 1.1 to up to 20 bars, right? These are other units. So, for example, in industries for different heating and processes, then these are called medium pressure boilers. High pressure boilers, higher than 20 bars, right? For example, in power generation and large scale industrial processes. Then we also saw in chapter 2, so this is mainly the range and for steam power plant, right? Normal steam power plant. But here, the supercritical, we saw one TS diagram of a supercritical cycle in chapter 2, if you remember. So those are very high pressure boilers. High pressure means here when the pressure is higher than the supercritical, higher than the critical pressure of water. So that is about, because this critical point of water is about 22 megapascal. All right. So if the pressure is higher than this one, or 22,000 kilopascal, or 221 bars, so then these are known as supercritical boilers, right? Because they are operating at such high pressure. So they are ultra efficient modern thermal power plants. But majority of the boilers which are used for steam power plant, those fall in this range. Right? Okay. Okay. So major types of boilers can be classified into, according to their construction, they can be classified as fire tube and water tube boilers. So here in this figure, you see a schematic of a water tube boiler in which water is flowing inside these pipes, all right? And these hot gases from the burner, from this combustion, they are flowing over these tubes, all right? Or outside those tubes. So these combustion gases, they heat the water and convert it into a steam water mixture. So here you see a bigger drum, here you see a small drum at the bottom. So for example, in this particular schematic, liquid water or cold liquid water is entering from the bottom, and then it is rising in these pipes because heat is supplied. So water will start uh, to gain heat and temperature will start to increase, density will start to drop. So this water will start to rise up in these pipes until it reaches in this upper cylinder or upper steam drum, right? Here the steam will be separated from the top and the liquid which is settled at the bottom will flow back again, and this cycle will keep on repeating. So this steam which is produced, that is actually a saturated steam, depending upon whatever pressure we want. So this steam will leave, and here you see this is a superheater. If we want to heat that steam to a superheated temperature, so there, here you see another heat exchanger, right? So this is a superheater or superheated heat exchanger or superheater. So here we can superheat with those combustion gases which are also flowing over this superheater. So this schematic is describing a water tube boiler, right? So here, this is one schematic. Here you can see another schematic of a similar water tube boiler. So here you see a bigger shell. Here water is entering into that big shell, and then it is flowing downwards by gravity, this liquid water. Now here in this inclined tubes, it will be heated up and it will rise up by itself because its density is dropping. So until this reaches again into that vessel, so vapor will be separated, liquid will again go down, and this process keeps on working like this. And this steam, saturated steam, is leaving from the top. Right. So there could be many different designs. These are just two simple schematics are shown here. So we shall see some practical designs in coming slides. So these are called water tube boilers because water is flowing inside the tubes. All right. So some basic terminologies mentioned here. These are called downcomers because it is bringing that liquid water back to this section so that it can be reheated again, right? Because the steam will be separated from the top, and whatever liquid is remaining, it will flow back, and the same process will be repeated. Second major classification of boilers are fire tube boilers, as you see here, as the name indicates. Now the hot gases are made to flow through the tubes, not the water. Like here, it's more clear. Water is stored or placed inside big vessel, and in this big vessel, there are tubes in which these hot gases are actually flowing. So now hot gases are inside the tube, so that's why these are called fire tube boilers. So this hot gases of combustion from here, and they are flowing through a series of those tubes, which is surrounded by liquid water. Right. So the energy from that gases is transferred to the water, which is surrounding them. So steam is generated in that water, and naturally comes up from here, whatever steam is generated, and is stored upon the water in the same vessel of this fire tube. So the steam is collected here, stored here, and then according to the requirement, this valve will open and steam will leave. Right. So these are the exhaust gases leaving after rejecting its heat to that liquid water. So these are called fire tube boilers. Right. So just a quick comparison. Normally water tube boilers, they are okay, this is clear. This is flowing in tubes. This here gases are flowing in the tubes. Pressure here, these are low pressure boilers, these are high pressure boilers. So why water tube boilers are used for high pressure applications, or high capacity? If the Q dot is very high pressure, you want steam at a very high pressure, for example in power plants or industries. So then normally these water tube boilers are used, right? Because there is a very small water content in those tubes. So because there is small water content available, so that's why water is heat up rapidly, right? So there is a fast response in these water tube boilers, right? So because these tubes are containing only small amount of water volume, so they heat up quickly and they can respond to rapid load changes. So those are ideal for power plant applications or for large industrial process. Right. So tubes, these small tubes, they can sustain high pressures very easily. Right, because if you remember from mechanics of material, the hoop stresses are given by P into diameter divided by 2 into thickness of that tube. So smaller is the diameter, smaller will be the stresses produced, even if the pressure is very high. But we can reduce these stresses by decreasing the diameter in which that fluid is contained. So smaller diameter will result in smaller stresses, all right? And they can operate at very high pressure. This 100 to 300 bars, they can easily operate. And they can produce that superheated steam up to 500 and 600 degrees Celsius, which is a typical temperature for steam power plant. And also they provide much larger heating surface area, right? So very high steam generation rate in case of water tube boilers. So high heat transfer rate, very large steam production capacity in case of water tube boilers. So if this water tube boiler fails, for example, so only a small amount of water will flashes into steam. So damage is limited. Maybe only one or two tubes will damage, not the entire structure. But if a fire tube boiler, for example, it will fail, so a huge amount of water will flash immediately. So this explosion here in this case is catastrophic compared to water tube boilers. Right. The major advantage here that the construction is simple. Here, construction you have to make those water tubes and put it into a proper angle, etc. Large heat transfer area. So here the overall construction or the overall cost is much more. Here it's simple construction, so those can be used for small pressure applications, right? Right. So here are the names of those practical boilers. We'll see some of them in this slide. Okay, any questions so far? So these fire tube boilers, they are slow response, right? Because here is a huge amount of water which is placed, which is to be converted into gas. So here it's the shell diameter is very large, right? So that's why here the pressure cannot be very high, because look at the same equation. If diameter is very high, pressure is also very high, so the stresses will become too much. So that's why here those are limited to pressure up to 25 bars, these fire tube boilers, right? But their construction is simple, that's why it's cheaper. So these are used for small and medium industries, or for small, only for heating or low pressure applications, not for power generation. So for power generation, these are mainly water tube boilers which are used. Okay. So this is also mentioned here. So just go through it. Next, now we shall see some practical boilers or industrial boilers which are used. So here you see fire tube boilers. So let's see some fire tube boilers. So as you can see in the schematic, so here is the portion that is the furnace where hot gases are produced. So this is a simple vertical fire tube boiler. These are used for small steam demands. So here you see a dome shape from the top with cylindrical shell. This shell is cylindrical type, and hemispherical end from the top. Right. So this is a very compact boiler. It requires very small space. Here, I think there is a picture, a real picture of Cochrane boiler. So the major components of this boiler are mentioned, and their names are also mentioned here. Right. So, for example, this G is representing grate. Now, what is grate? Grate, it is actually a kind of platform in the furnace upon which the fuel is burned here. and it is made up of normally cast iron bars, right? So these bars are arranged that air may pass on the fuel for combustion. So the area of the grate on which the fire is resting in a coal or wood-fired boiler is called grate surface, right? So here FH, for example, you can read it. That is the fire hole. We can see or observe the firing through that hole, right? So and so on. You can see, for example, what is this CC? That is the combustion chamber, because here is the furnace, and this space is named as combustion chamber. Now these hot gases are flowing through these tubes, and this is all water, liquid water. This one. So these tubes are passing through this liquid water everywhere. You see these dotted lines. These are representing liquid water. And hot gases, while flowing through these tubes and after transferring heat to that water, they are leaving from that chimney, right? So all these abbreviations are mentioned here. SP means smoke box, right? The C means chimney. Okay. Um, Here you see that is anti-priming pipe, right? So what is this thing? It is a special pipe which is used in these Cochrane boilers and also in some other types. So what they do, they reduce or prevent the priming. Now, what's meant by priming? The water droplets, which are the liquid water droplets, which are leaving with this gaseous steam. So uh, they prevent those liquid particles of the water uh, to go out, to leave with that steam, right? So now what is this SV safety valve here at the top? If the required pressure is greater than the required one, so this safety valve will open and the steam will leave. If the pressure of the steam gets too big here, right? So similarly, you see here PG, that is actually a pressure gauge to measure and the pressure produced in that boiler, right? That MH is manhole through which we can see, right? Manhole. So any person can see inside the boiler through that part. Okay, so there are so on. There are many such components in any, because this boiler is not a very simple device. It contains many such components. Especially, I was explaining this anti-priming, right? Uh, it is normally fitted at the top, right, of that boiler shell. So it separates steam from the water droplet. So it will ensure that only dry steam is leaving into that main steam pipe, right? So this SSV is representing steam stop valve at the top, this one. So this valve is open according to the requirement of the steam. And before this SSV, this is APP, anti-priming pipe. So what this anti-priming pipe, it reduces the velocity of the steam and allows this moisture to fall back into the water, right? So there are small holes in this anti-priming device. Okay, so then there is also this thing, what is BOC, blow off cock. The removal of mud and other impurities which are collected at the bottom of this water shell, right, in the lowest part of that boiler. So that is called blowing off. The term which is used to clean this mud and other impurities, this process is called blowing off. So this is accomplished with the help of a blow off cock or valve. This is blow off cock or valve. So this is a construction of an actual boiler, fire tube boiler, which is named as Cochrane boiler. Let's see some. So here you see another. So all these definitions are also here. Maybe I missed this one. This is a fusible plug here. Here you see this one. So what it does, it melts at high temperatures if due to low water. If the water quantity is here low and temperature becomes very high, so what it does, it melt. This is made up of a material which will melt. So when it will melt, it will block this passage, right? So it will make this fire to go off by releasing water. So when this fusible plug, then when it melts, so it means water will start to flow here and it will make this fire to go off in case of emergency. So that is a fusible plug. So all others you can simply study. It's not that difficult. Okay. Here you see another picture of the same Cochrane boiler, so you can understand it's it's working. Here water is very clearly shown. All this blue color is showing liquid water, and here is the steam which is being produced, right? Anti-priming pipe, which I was telling you. Here is the steam stop valve. The steam is collected from the top. So this portion of the boiler which we are seeing here, that is only to produce saturated steam, not superheater. So there is no superheater in this particular type of boiler, right? So it is just producing steam at saturated pressure and temperature. Here we see another type of boiler, which is called Lancashire boiler. It is another type of fire tube boiler, right? Its working is a bit, so there are different views, which sometimes confuses to understand its working. So that's why let me try to explain. Here you see again the main shell. If we see from the side, here is the main shell in which this is representing water. And these are the two tubes in which the fire or the hot gases are traveling, right? So because it's a fire tube boiler, right? So these are horizontal fire tube boiler with two big flue tubes, right, running through it, across it. So if we see from the top, so here is the top view. This is side. So from the top, we can see these are the tubes through which this fire is traveling, or hot gases are traveling, and surrounded by water. Okay. Now, what happens at the end, and also you see those tubes towards the end, those are shaped conical. So they are producing a nozzle effect. And so, because of these nozzle effect, the velocity of those flue gases increases. Because here, these gases are produced at a high pressure, and this here, because of this nozzle action, low pressure is created and velocity is increased. Now, once these flue gases reaches towards the end, then they go to the bottom. Okay, so here we cannot see the bottom, that is the top view. So bottom we can see here. So flue gases are traveling first through these long tubes. At the end, they go to the bottom. So, and they come out from the bottom. After they come out from the bottom, they travel to the two sides, right? Two sides of that vessel. So those, when they travel from the two sides, look here. So here is the side, we can see that side. If we see this from this side or from this side, then the view is like this. Okay. So from this side, we will see only one tube, one fire tube, which is this one. Actually, there are two, but from this side view, we can see only the further. So then if I say this is side view, this is top view, then I would say this is front view or cross-sectional view. So now those gases coming out from the bottom, they travel from the sides of that vessel, and then they finally leave through the chimney. Okay, so let me show you some other picture. For example, here you see another picture So here are those fire tubes, and at the start of those tubes, here is the combustion taking place, all right, combustion of any fuel. And here those tubes, those gases are traveling through this tube. Okay, here you see that bump or hump, which will ensure that gases are traveling in this particular direction. They will not go back. That's why this hump is provided. So here these are surrounded by liquid water, and whatever water will be evaporated, that will leave from that. Sorry, that is the stop valve. That is the safety valve to monitor the pressure. Okay. So again, this is the cross-sectional view, that is the side view, here is the top view. So from the top, you can see both holes. So these are going here. Now it goes to the bottom, right? Here you can see the bottom. And then they come out from that bottom here. Then they travel from the sides. So sides we can see again from the top view. The two, so first they go like this, then through the bottom, then they divided into two sides. And from these two sides, they are now finally leaving. Here is the chimney towards the end. Okay. So if you do not understand the construction, so you can see any video animation on YouTube for Lancashire boilers, so you will understand it. So this is another type of fire tube boiler. Here we can install a superheater. For example, here we can make this steam which is leaving from this, and here we can have another superheater towards the end when it is taking a turn. So here we can have a superheater, and after it is going to the chimney, before going to the chimney, here we can have an economizer. So that is also shown in this particular diagram. So here are the hot gases going through those tubes, horizontal tubes. Towards the end here, before it goes to the bottom, here are the superheater. And this steam which is leaving from the top, from the main shell, it goes into this superheater tubes, right? So we can get this superheated steam. So towards the end, the same hot gases, they can superheat that water. And after that, now it goes to the bottom, then it goes to the two sides, right? Before going to the chimney, here you see another bundle of tubes that is acting like an economizer. Right? So now you can see these three portions: boiler, this one, here is the superheater, and this is the economizer. Right? So the coldest water is entering into the economizer. This water will go into that vessel. That connection is not shown here, and then it will be become saturated and then superheated. Right. Okay, that is explained here. So here you see another picture of that Lancashire type boiler. Okay. So, locomotive boiler, that is also a horizontal fire tube boiler, right? Here construction is not that typical. Here you see that grate where firing is take place, and these hot gases are now traveling through tubes, and here it is surrounded by water, right? So this is a locomotive type boiler. It is also a horizontal fire tube mobile boiler used in railways. Not anymore, because now modern railways, they are running on electricity. So you don't see these type of locomotive boilers nowadays. Those have become obsolete now. So okay, so then no need to consume time over that construction. Let's move on. Here, that is a type of a water tube boiler, which is called Babcock and Wilcox boiler. So here you see a big shell in which water is stored. And this water tube with inclined water tubes are installed here, right? Those are connected to this main steam drum. This liquid water flows towards these tubes. These tubes are arranged in some angle theta, right? So water will circulate naturally due to density difference in these tubes. So they flow downwards by gravity, then they flow upwards by density or buoyancy. So water enters from the drum, right, from here, flows through these tubes, gets heated up, and return here. And here steam will be separated, liquid water will flow back again. All right. So this has high efficiency and it is capable of meeting large steam demands. So these are suitable for mainly for thermal power plants and industrial process heating. And here you can also see superheater. So here are the hot gases which are moving like this over these tubes. Okay. And finally they are going towards the chimney, right? So D here means doors, I think. Yeah, D are doors here. This is the same anti-priming pipe, right? So steam, whatever steam is leaving, it is first flowing through this anti-priming device. So water liquid is separated, only saturated steam is flowing through this tube. What is this tube? That is a superheater. So once the steam gets superheated, then finally it is leaving from that stop valve, main stop valve, MSV, to the turbine or wherever it is required. So the rest you can simply go through, right? So you just need to have a basic idea of that schematic. Okay, so that is a water tube boiler. If you have any questions, you can ask. The rest, if you are interested to go into more details, so just go through the notes or the book which we already shared in the teams. All right. Here, okay, that's clear. So here you see another picture of the same Babcock and Wilcox boiler. So here is liquid water, and here it is steam. Right. Here is the fuel which is getting combustion. This is superheater. This one, superheater. Here the steam is leaving from that valve. Right. Blow off cock to clean whatever mud and impurities which are collected. Those can be taken out from this part, from the bottom. Here is the chimney, all those gases which are combustion gases which are flowing like this, they will leave from that chimney. Okay, so all these boilers, they have some necessary accessories, as I told you, economizer and superheaters. Those are not considered a part of the boiler itself. So what is the purpose of the economizer? We already know in from that graph of TS diagram, that is the part which is called economizer. That is the part which we are naming as boiler, and that is the part which we are naming as superheater. So what is that economizer? It's just a heat exchanger, right? Water is entering, for example, that particular schematic is describing the construction of a economizer. So hot gases which are leaving the boiler before going into the chimney, they are made to flow over these set of tubes, right? So here liquid water is entering and flowing in these tubes and collected from the top, hot water. So here is the cold water, This hot water will now enter into the boiler, right? And these are the flue gases which are coming from the boiler and superheater part. Now their temperature is low, but still this temperature is good enough to heat this cold water. All right. So boiler efficiency can be increased if we include that economizer to preheat the water before entering into the boiler. All right. So here you see these, because here the flue gases which have many impurities or ash contents in it, so that will be deposited on these tubes. So after some certain time these tubes needs to be cleaned, so for that case these are installed. These are called soot scrapers, right? As you see, soot scrapers to remove the soot, because those are actually they are the ones who will decrease the heat transfer efficiency over time, right? Okay, so that is simple. You can simply go through. Then economizer, it could be of different types. It could be simple tube or tube with fins to increase the heat transfer. These are, so fins could be rectangular shape or circular shape, all those which we covered in heat transfer, right? So as I told you, there will be a scraper or soot blower that will clean the soot deposit from the economizer tubes, right? Because that soot act as insulator that will reduce the heat transfer and lower the efficiency. Okay, next, superheaters. Superheaters, they are responsible. For example, here the water is converted into steam, but that steam is saturated. To convert it into superheating, so this steam is again sent to another heat exchanger, this one. So this whole part is actually acting like a superheater. From the same furnace, those hot gases, they are flowing over these tubes, which are acting like a superheater. Okay, so here is the some basic details about superheaters. If the temperature is below 450 degrees Celsius, standard carbon steel is used. The material of those superheating pipes, if the temperature is in this range above 500, then we need special high strength alloy steels for strength and also for corrosion resistance. So these superheaters normally they are placed very uh, close to hot gases, right? Because here we need to increase the temperature to the highest temperature, right? So the heat transfer mode in these superheaters, those tubes which are very near to the flame, here is that flame, highest temperature flame, by the combustion of those gases. So those tubes which are very near to that flame, here the heat transfer will be mainly by radiation, right? And those tubes which are a little away from that flame, here the convection is more dominant, convection heat transfer. But in the here, because the temperature difference, because the temperature in this furnace will be around how much? Maybe it could be 1200 to 1600 degrees Celsius, right? So at such high temperature, thermal radiation, because if you know, thermal radiation is directly proportional to temperature to the power 4, according to Stephen Boltzmann law. So that becomes the main mode of heat transfer, those tubes which are near to those gases. So that is here radiation or radiative heat transfer is more dominant. All right. And also here the speed of those gases in this initial region, gas velocity, is also not very high. Okay, so because they are just rising from the flame, right? Okay, but those tubes which are away from those highest temperature of flame, now the flame is flowing with a certain velocity, right? There could be some blower or fan which is making these flue gases to move, and also the temperature of the flue gas is now dropped. So here main heat transfer is by convection, all right, because the temperature of the steam is already increased, and the temperature of the flue gases, which was highest here, but now those are also dropped. That's why here this is called convective superheater, and this is called radiant superheater. So superheater can be divided into two major portions: one where radiation heat transfer is dominant, and the second where convection heat transfer is dominant. Right. So the rest just quickly go through, because there will be maybe few MCQs in the exam. Okay. Now, as the steam flow rate, required steam flow rate is increased, because here is the steam which is going to the turbine section. So as the load increases, so the amount of steam which is required will also increase. So as the steam flow rate increases, this radiative heat transfer will start to drop, because now the steam is flowing at a higher rate, right? So there is less time for this radiation heat transfer to travel or to transfer, right? So the flame temperature remains constant, about that 1200 to 1600 degrees Celsius. That will not change with the high speed of that steam, all right? So steam exit temperature drops, because now steam is moving at a higher rate, so less time is available for proper heat transfer. So radiation heat transfer with high steam flow rate will start to drop, right, as the steam flow rate is increasing, depending upon the capacity of that power plant. But as the steam flow rate increases in the convection part, with the increase in velocity, we know the heat transfer coefficients increased. So the convection part will be increasing. The convection heat transfer will be increasing with time. So the overall effect is shown something like this with the increase in. So overall response remains quite stable, right, with the increase in steam flow requirement, right? Okay, so this is a general description of how the radiative and convective part of that superheater will respond to high steam flow rate. Okay, so that is explained here. Overall, the comparison of these superheaters, it could be all convective superheater if those tubes are away from the main flame. If the tubes are very near to the main flame, then this is acting like radiant superheater. And the one which we saw, it was a combined in-series superheater. Okay. So convective means it is away from the main main flame, or they are shielded from the main flame, right? So they are protected from direct flame, but here it is exposed to the highest temperature of the flame. Okay, that is a kind of a balance. Okay, so main heat transfer mode is convection, here it is radiation, here it is combination of both, right? Location, as I already told you, response to load, steam temperature increases with load for convective, but here steam temperature will decrease with load, because the radiation heat transfer does not depend upon the flow rate of the radiation heat transfer is only dependent upon the temperature difference and to the power of temperature difference to the power of 4, t to the power 4 minus t to the power of surface, the other surface, pipe surface. So it is not depending upon the load or steam flow rate. That's why radiation heat transfer that may drop at high mass flow rate. Okay, so the rest you can also go through. That is a brief comparison of different superheaters. In some power plants, they also use preheaters, because in that combustion chamber, here we are supplying air and fuel. Right? That is the combustion or furnace which is producing that hot gases. Okay. And that hot gases are going into that boiler or a heat exchanger. So in that combustion chamber, we may preheat that air because this air is coming from the ambient. So the hot gases of that boiler, after economizer, if their temperature is still high enough, they can be used to heat that air, which is going into that combustion chamber. So these heat exchanger with hot gases on one side and air on the other side. So here we can use such a heat exchanger plate, uh, this plate type or that bundle of tubes. So here is the atmospheric air. Now it is made to flow over these flue gases coming from the boiler. Boiler means, again, this boiler has three parts: economizer, boiler, and superheater. So highest temperature of hot gases, they go to the superheater, then boiler, and then to the economizer. But now still their temperature is high enough, so that can be used here before leaving into the ambient through that chimney. So those hot gases can be used to preheat that air. That air is now used here in the combustion chamber. So this is called air preheater. So in some boilers, air preheaters are also used. So they preheat the air supplied to the furnace or combustion chamber. So those are installed between economizer and chimney. So if I say this is chimney, so between economizer and the chimney, we can use this air preheater, right? So this degree of preheating depends upon what type of fuel we are using, right? Fuel burning equipment or boiler or furnace operating range, that will decide how much preheat is required. So these air preheaters, they are also heat exchangers. Tubular type flue gases passes inside the tubes. These are flue gases which are flowing through those tubes, right? And the air is flowing from the other side over these tubes. So it's more like a shell and tube type heat exchanger. It could be, so this is tubular type. There could be a plate type heat exchangers, which we saw in heat transfer. So air preheaters are sometimes also used. Okay, I just need to pause. There is a phone call. Okay. So this is air preheater. It's a simple theory you can easily understand. And here is, you see a complete picture of that power plant. And in that complete picture, we are discussing this boiler. So here you see, this is the boiler part, right? Here is the superheater, all right? And here is the economizer, okay? This is the burner and fuel, and this is the air and fuel which are supplied to that burner. Now that air is coming from that air preheater, right? Before this, these gases are leaving to the ambient, right? There are SO2 scrubber because you need to clean that these exhaust gases. So I think here, for example, that is the ambient air which is coming in. Now it is preheated here. Now this ambient air which is preheated, now it goes into that burner in which fuel is separately supplied. So here in that burner, this air fuel mixture, those are mixed together, and then they are burning here, and this heat is supplied to that to these tubes, which are risers. What are these risers? In which this water is coming from that steam drum. Now water is getting heated up and it is rising. So in the steam drum, steam is separated, saturated steam. This saturated steam is going into the superheater. Right from that superheater, this steam is going into the turbine, and these are the exhaust gases. Now, if you are using a 2-stage turbine with reheater, so here you can see this reheater. So this steam is again sent to a reheater. Reheater is again, after superheater, you can install a reheater. And then it goes into the second stage turbine. And these are the hot gases. Now it is these hot gases are flowing over the economizer. What is the economizer? In that economizer, liquid water is coming from the condenser. So here you see that pump. Okay. Now this water is preheated, right? Again, this part. This is happening here. Then this part, boiler, this is happening here. Then this part, superheater, is happening here. Then after superheater, there is a turbine. Okay, first turbine. Then there is a reheating. So this reheating is occurring here. So all the possible components are shown in this particular picture or schematic. So here is that complete boiler process is shown with air preheater, economizer, superheater, reheater, and saturated water, saturated steam, which is produced here. Okay. So the rest you will go through by yourself. Okay. It's not that difficult. After that, here are the typical temperatures for each stage is mentioned. Air is entering at 25 to 35 degrees Celsius. Now here in the air preheater, temperature may be increased up to 300 to 400 degrees Celsius. Then in the furnace here, the right temperature is written 1200 to 1600 degrees Celsius. Then in the steam drum, as an example, steam is produced around 230 to 260 degrees Celsius. Then in the superheater, temperature is increased to 320 to 350 degrees Celsius. Then in the reheater, again, up to 300 to 350 degrees Celsius. Then in the economizer, the water is heated up to 110 or to 150 degrees Celsius. In the condenser, this water is coming at around 40 to 50 degrees Celsius. So those typical temperatures are mentioned, inlet to outlet, right? So here it's just one particular example is shown. Okay, typical example. Okay. Now, after that, the numerical part, it's not that difficult. It is again based on chapter 2. So we shall do it in today's tutorial class. Okay. So we'll do that numerical part in the tutorial class that was already recorded also. So, but this theoretical part was not recorded. So that's why I have recorded today. Okay. So I was a bit fast because it's just last week. So that's why I'm going through quickly, but the main important part from this chapter is this numerical part, which may be linked to the other chapters, okay, steam turbine or nozzle. So these are 2, 3 numericals, which we will do it in the tutorial class today.